Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat. There you will also find useful links. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and our speaker today is Jim Bennett, who is a regional cloud advocate. I'll now turn it over to Jim.
Awesome. Thank you very much. Hello, everyone. Good morning, good evening, good afternoon, good night, wherever you are in the world. Welcome to session 2 of TinyML with the Seeed XIAO. Last week, I took my Seeed XIAO, I used it to capture running and rowing data to build a fitness tracker using Edge Impulse, and I deployed that model to my device. Today is all about connecting this to the cloud via Bluetooth and a mobile app. So we're going to play with some Bluetooth on the board, a mobile app, and the cloud. So let's dive right in, and let's just do a quick recap of what we did last time. So this here is my fitness tracker. It's my little teeny tiny Seeed XIAO there. It's a very small microcontroller. It's got Bluetooth on board, Zigbee, no Wi-Fi, but it's got accelerometer and a whole load of other bits and pieces. It's a great little board. It's about $14 to buy one of these. Probably out of stock everywhere because, global supply chain shortage. But if you can get one, it's a great little board. And this is the microcontroller I was using last week. And then I was using Edge Impulse, which is an online tool for training tiny machine learning models. And these are machine learning models that are tiny, hence the name TinyML, but they run on small microcontrollers like the Seeed XIAO. So what we did last time is I set up a data streamer on my Seeed XIAO that captured accelerometer data, X, Y, and Z data, and then it sent that up to Edge Impulse. And then from Edge Impulse, I was able to classify my data. So I collected my data. I had these different samples that showed measurements on the accelerometer. I was then able to build a classifier in Edge Impulse terms as an impulse. We took time series data, ran a spectral analysis over that, and spat out a classifier to classify between rowing and running. And then once I had that, I was able to export my model, deploy it as an Arduino library, and then use that in my code. Now, anyone who was here last week, and if you were, please say in the chat. I'd love to know whether you joined, whether this is your first time or second time joining us. But if you were here last week, you may have remembered I hit a small problem. I had this wonderful problem where when I tried to program my device, it wouldn't deploy my code. Now I have the solution to that problem, and the problem was something I really should have remembered because I've hit it before. So it turns out, if you have a USB sound card, in my case I've got a Focusrite Scarlett 2i2, fantastic USB sound card, allows me to connect lovely microphones to it via balanced inputs. If you have a USB sound card like that, and you're connected to StreamYard, which is the streaming tool we use, via a Chromium-based browser, such as Edge or Chrome, you can't program IoT devices. I have hit this before. It's not just to do with the Seeed XIAO. I've hit this on other devices before. So yes, if you are live streaming over StreamYard and you have a external audio input like my Focusrite, it means you can't program IoT devices. Now, it doesn't happen with other microphones, so I don't know whether it's just because my audio input runs at 192 kilohertz. I haven't dug too far into it, but essentially it meant it didn't work. So my fix for today is I'm using Firefox rather than a Chromium-based browser. So now I can program my board. So that was what was happening last week. It wasn't a problem with the tweaks I had to make to enable the Seeed XIAO to work with PlatformIO. It wasn't a problem with my code. It wasn't a problem with the board. It was this lovely lack of working between Chromium-based browsers, my sound card, and the board. So this is the code we were working on last time, and I put in a whole lot of code here that read from the gyroscope, based off the size of the input to my classifier. So the classifier was based on 1 second's worth of data. We capture a second's worth of data on the device, and then we run it through the classifier, and we print out the output. And so if I just upload this to my device, we can actually see this in action. While it's uploading, I'll strap on my BitFit. If you remember, we're working on the BitFit, our fantastic fitness tracker device. There we go, uploading, because I'm not using a Chromium browser. Strap this on, and then hopefully, if I bring up the serial monitor, you see we've got prediction. You actually see I'm getting the predictions here for rowing and running. And then if I start running, let's do running, we'll see majority of the time we get a 1 for running. Occasionally there's a 1 for rowing, because I've only trained it with a small amount of data, but the majority of the time we're getting 1 for running. And then if I stop, there we go, it goes back to nothing. So that's the model all deployed. And this is great. I've got my microcontroller working, I've got it gathering data. This is doing what your Apple Watch or Fitbit would do. Obviously, trained with a lot less data than those devices. So now we've got the problem of I need to get this data off my device and up to the cloud. I want to better track this in the cloud. I want to see my fitness on a web page. I want to better run AI models to predict about how I can get better at my fitness. I want to report on it. I want to get emails to say, hey, Jim, you haven't been rowing for the past week. Things like that. And to do all that, I need this data up in the cloud. And the way a lot of these Bluetooth-based fitness trackers work is they sync via your phone. Everything goes via the phone. So instead of having connectivity on the fitness tracker has something like Bluetooth on it, which connects to your phone connects to the cloud. And one of the biggest reasons for this is Bluetooth is low energy. Even here referred to as modern Bluetooth is known as BLE, Bluetooth Low Energy. And so the power draw of a Bluetooth device is relatively low. So that way you can get a device like a fitness tracker, Fitbit, you plug it in and it lasts a week on a single charge. It's teeny tiny little Fitbits, yay big, tiny little things, can charge it for a week. And that's because over Bluetooth, they only issue a small amount of power. If they put Wi-Fi on the device, it will just drain the battery much, much faster. So this is what I can do. I can use Bluetooth on the board to connect that to my phone, and then from my phone up to the cloud. So I'm just going to stop my serial monitor there. That's it, go away. And so I've started writing some Bluetooth code. Now, if anyone's done Bluetooth, let me know in the chat. I'd be interested to know how good you are at it. I've dabbled a bit. So, if you've done Bluetooth before, I might come to you with some questions, depending on how it goes. But I've been setting up Bluetooth on my device. Now, the Seeed XIAO, it has Bluetooth on it. It's one of the connectivity mechanisms on here. And the Seeed XIAO is Arduino compatible, which means I write using Arduino code. I coded up, standard Arduino libraries. And because it's Arduino compatible, Arduino libraries should work on the board. This is one of the cool things about Arduino, is when you add an Arduino library to your code, it downloads the source code. So you get the raw source from Arduino, and then that gets compiled for your board. So if you have a platform that's got a new chip in it, Arduino code will still work. It just gets recompiled for your chip. So it's not like in the Arduino libraries they have to publish every single compiled version of the library. They have to publish it for, Cortex M7s and NFR boards and blah, blah, blah. They don't publish all the different board versions, whatever. They can just publish the source code and you bring that down and compile it. And there is an Arduino Ble library, which is pretty cool. In fact, if I go to my PlatformIO libraries, Arduino Ble, search for that. In fact, it's called Arduino Ble, I think. Arduino Ble. So this is an Arduino library. It supports a whole load of Arduino boards, including the Arduino Nano 33 Ble. It supports anything that's got a standard Bluetooth chip inside it. And what's really cool about the Seeed board is they've made it work with the Arduino Ble library. So I can add this library to my project and I get Bluetooth low energy capabilities inside my device. which is pretty cool. So they would have made changes inside the code, they would have put stuff in the code to make it work with the Seed board. So the PlatformIO, I use my PlatformIO.ini file. This is the configuration file in PlatformIO I can add my library to, and that will then bring in the library. And so I just import Arduino libraries, Arduino Ble. We did this last week with the LSM6DS3 library, the library for the accelerometer inside the board, but now I'm adding the Arduino Ble library. And upon adding that, what that does, in my .pio folder, which is a magic folder that contains all my code, that actually downloads the code to the Arduino Ble. And this literally just clones a GitHub repo. So the Arduino library is just a GitHub repo. It's got a properties file that specifies some information about it, and I just clone this and it gives me all the code. And here's all the code here for managing Bluetooth. And say this all works with the Seed board. It gets compiled down to work and run on the Seed board. Now Bluetooth is an interesting protocol. So there's kind of there's standard ways of communicating over Bluetooth. And so the idea is you have on your I think they get the kind of client and server thing around a bit of a weird way, if I just in terms of how I understand it. But essentially, your Bluetooth client advertises information. So on your client, you run a Bluetooth service that's a named service, and that name tells you what the service is that you've got available. And so other devices can look for a service by name. And then once you connect to that, sorry, it's not a service, it's I really need to learn the proper terminology. Essentially, you have a Bluetooth device. Sorry, the Bluetooth device advertises itself by name, and so that name can be kind of unique, but usually that name is fixed for a certain type of device. So I would have a device called, my BitFit, for example, and then all my BitFits would advertise with the name BitFit, and they'd just be identified by different kind of addresses under the hood. And then for my device, I have a service, and you can have multiple services on a device, and each service provides certain capabilities. So I could have a fitness tracking service that tracks things like the activity I'm doing, but I could also have things like a battery service. And so that service would publish battery data. And certain of these services are standard, kind of industry standards. So the Bluetooth battery service is fairly standard. In most devices with a battery, publish the same battery service, and then you can interact with that battery service the same way to query how much battery do you have left. That's kind of a standard they have. Now, these services are indicated by unique ID, but obviously if you go for a well-defined service, it has a fixed ID. So the Bluetooth battery service has a fixed ID. I would publish a service with a certain ID that says, this is my battery. And then inside a service, you publish things like characteristics. And characteristics are things that can be read or written to. And so I've got a characteristic inside my fitness tracking service for my current activity, and then with that I can then read the value. I could also write a value if I wanted to, and there's a thing called notify, and notify allows the Bluetooth device to notify anyone who's interested that the value has changed. And so a characteristic, it can be I can write to it, I can read from it, or I can get notified when that changes. And so what that means in terms of our fitness tracker is we have a Bluetooth device, a BitFit device, that has a fitness tracker service on it with a certain ID. And then in that service, we have a characteristic, which is whether the device is read-only. It's a characteristic that we can read, and that's the current activity. And that we want to have that notifying as well, to so notify our phone app that things have changed. So the way we do this in Arduino, we have a service and a characteristic, all define unique IDs. We kick off the Bluetooth stack. So we do, Ble begin. That kicks off the Bluetooth stack. So that's actually start the Bluetooth running, start the radio inside the device listening. We then give it a name. So our device has a name. Cool. And this fit track, probably call it BitFit, really, shouldn't I? Let's call it BitFit. That's the name I want to give it. BitFit. Call it BitFit. We then add a characteristic to our service and add our service to our radio. So we kind of build up this hierarchy of characteristic, which is our activity, belongs to our fitness tracking service, that belongs to our Ble device. And we add the service and we advertise it. So you can only connect to services that you can see, and advertising is about showing the services you can see. So by doing this, we advertise what the service devices can connect. We can then set a value on our characteristic, which is what the values are going to read, and then start advertising. And once we start advertising, the radio goes on and we can start pulling data off the device. So that's the kind of Bluetooth setup I do. In my Arduino setup function, I set up my Bluetooth Low Energy device, get that going. And then once we're going with that, in my loop code, I launch I attach to the kind of the core device that gets it working, and I listen to see whether we're connected. So you have this device, it's called Central, and I've no idea why they call it Central, but it is called Central. When I connect to that, and that is the device, so I can listen to see if I'm connected. So in my loop code, I will check, am I connected to Bluetooth? Because if no one's connected to me, there's no point in me transmitting any data. There's no point in me checking the fitness, because the moment I just make sure I'm connected. That's just how I've decided to do it at the moment. I may want to cache the data and then sync it later when I'm connected. Depends how I want to do this. But right now, I don't want to cache any data. I just want to send the data up to the cloud when I'm connected. So if I'm connected, simple. If I get one of these back, we have a centralized connection. I'm logging out the address of the connection, and then all the while that we're connected, I'm pulling data. So I'm getting the activity. I've run a bit of code here that will run our model to get the activity. And I've actually got a slight tweak to this code, because rather than get it every single time, this model actually polls for 15 seconds and looks the most likely activity over 15 seconds. These AI models are never going to be perfect, but it's unlikely I'm going to be running 1 second, rowing the next, and doing nothing the next second. And so I kind of look over a period of time and get an average value for the activity I'm working on, and then I update that. And my update call, what that will do is if the last activity has changed, it'll actually write it to my characteristic. And when you write the value to the Bluetooth characteristic, if that characteristic is up to notify, that will then send a signal out to any devices that are connected. And so let's kind of show this in action a little bit, actually. Let's just show this in action. I'm just going to deploy this code to my device and make sure I've got all the Bluetooth stuff there. And then I can see it in action with a Bluetooth scanner. So Bluetooth is very public. And so once you're advertising Bluetooth, anything can connect and pull data on or off. Kind of obscurity is kind of this, you can hide things, you can have things not advertised, but really it's not the most secure. You can have pairing, where devices have to pair with a certain code. You may have done this if you ever paired, I don't know, a phone to a car radio. Sometimes you have to type in a code to pair it, but for a lot of things that work over Bluetooth Low Energy, you don't have to pair them. You can just connect with anything. So I've got a scanner app called Light Blue. If I just go to my phone here, I'm running this scanner app called Light Blue on my phone, and what I should have, there's my fit track. I called it fit track before. I renamed it, didn't I? So let's see if we can find it. Because I called it something else. Okay, so it's still remembering it's fit track because I only just renamed it a bit. Let's see if that connects. So here, yep. So what it's done, if you look at my code here, my output from the serial port, it's connected. So this is the MAC address of the device that's connected. So now that it's connected, it's going through updating the data. So it only happens when my device is connected. And if you look here, this is my bitfit. This is my unique ID, 381884CB. That's the unique ID of my device. And then I'm advertising at 0D5B. If I go over here and go up to my, wrong window, go up to here, 0D5B. So this is my service. So it's picked up my service that I'm running. And then this here, this characteristic, BC9F, so that is my current activity, BC9F, and that's read and notify, read and notify. So if I click on this, if I tap on it, sorry, because it's on my phone, this is the last value it read, 0x00. So this is my none value. This is me not doing any activity. And if I actually listen for notifications, This is now connecting, this is listening. So now if I change my activity, I should see that feeding through onto my device. So I'm going to put on my BitFit, done my device, and I'm going to start running. Here I go, running. So this is kind of looking over an average of 15 seconds worth of data. So hopefully, if I carry on running like this, anyone suddenly just joined the stream right now, if you're wondering what I'm doing, I'm building a fitness tracker. So hopefully, in a minute, there we go. So it's picked up 0 times 0, 2, so it picked up running. Oh, and it dropped back to none. Yep, it's got running as my activity. So it's kind of picked up automatically that I'm running. So this is where it's set to, the characteristics set to notify, and then when we notify from the device, that updates it on the Bluetooth, and then that gets sent to any device that's listening. And so there's no security here at all. Anyone can kind of tune in and listen to this, which is, you know, kind of worrying, because I mean, if I go back here, yeah, there's a whole lot of devices here. Some on my computer that can't be connected, but yeah, any of these devices could be, could be someone's device, and I can attach them and potentially hack them. There have been cases where people have got Bluetooth devices which have been hacked because they don't implement any kind of decent security. But yeah, so that shows we kind of got a bit of success here. My device was connected, and I was sending data, and now you see it's disconnected. So when I disconnected, we got that disconnection notification. So again, my device can know when it's connected or disconnected, and that can affect the code I'm running. Yeah, I'm not running my AI model because I'm disconnected, so I'm kind of moving to like a low power state, and then only reconnect when the device is connected. Not totally low power, because I've got to sit here advertising my Bluetooth service, but a much lower power state. I'm not running my model continuously, which is pretty cool. So that gives me Bluetooth. I've now got data coming off my Bluetooth-enabled fitness tracker. So what I want to do now is I want to get this data up into the cloud. Now, the cloud doesn't have Bluetooth connection. There's not like, I don't have an Azure over here that I can connect to over Bluetooth. So this is where my phone comes in. And the standard pattern, you've probably seen this many times before, Bluetooth device connects your phone connects up to the cloud. So let's have a look at that. And I have got a mobile app I've written here that allows me to connect to the cloud with Bluetooth data. So I'm using Xamarin. Xamarin is a cross-platform tool, allows you to build mobile apps using .NET. So if you're a C# developer, you can write apps using Xamarin, and they run on iOS, Android, other platforms. It's a great platform. It's being replaced by a thing called Maui at some point in the not too distant future, which is kind of a cross-platform, does Windows, mobile, all different platforms. Fantastic tool. That's coming up. But right now, Xamarin is the tool of choice if you want to build cross-platform mobile apps using .NET. The reason for me for using this is there are libraries for the Azure IoT services in .NET. So it kind of made sense for me to have a tool I could use where I could just bring in libraries connected to the cloud. Now, actually, what I am going to do, I changed this from FitTrack to BitFit. I'm just going to put it back and just make sure it's deployed with it back, because I set up on my other code with the other name. So it kind of makes sense to stick with the name I know is going to work. So let's just deploy that. And so I've got this mobile app, but I need to get my code to the cloud as well. So before we dig into the details of the mobile app, let's have a look at the cloud side of things. Let's see what we're going to do on the cloud side, and then we can look at how we're going to connect the two together via my mobile app. So the cloud service I'm going to use is Azure IoT Central. Now, Azure IoT Central is an IoT software as a service platform. So this is a platform that is designed to allow you to build an IoT application in the cloud with no code on the IoT application, and kind of build it reasonably quickly by essentially dragging and dropping what you're doing. And so what you have in IoT Central when you start it up is, let's just go straight back to it. You start in a nice portal and go in here. Oh, they've got a summit coming up on the 7th of April. anyone's interested in learning more about IoT Central, I'm just going to put a link in the chat, actually. Link in the chat to the IoT Central Summit. You want to learn more about this tool I'm about to use? Link there in the chat for you. But IoT Central is it's a software as a service platform that allows me to connect devices to the cloud, visualize my data, manage my devices, and then do things like export data, alerts, queries, all that kind of stuff without really writing any code, which is really quite nice. And so I've got an app here. Here's my app, my BitFit app. And the way these apps work is you start with what's called device templates. And device template defines the data that your device is going to send to the cloud. So I've got my BitFit device template. And in here, I've got a model which defines the data the type of data my device is going to send. And I'm sending the current activity. And so I go in here, I fill in display name of current activity, the name I want the data when it's sent, but the fact there's telemetry, and I've got a schema which is none, running, and rowing. So I can say this is the type of data this device is going to send. And there's so much more I can add onto here. I could have other things. I could add things like battery levels. I could have commands that could be sent back to the device to request that my device does something. I can have properties that are kind of kept sync between devices in the cloud, and they set up the device and the device is connected. Loads of different stuff that I can configure on here. There's literally, it's all done just by clicking. Yeah, I can add, if I wanted, battery level, telemetry. Do I have a power on here? I wonder if I do. Yeah, power, you know. That's power levels. I wonder if there's a charge. Yeah, electric charge, maybe. Oh, it's in coulombs. But yeah, so they've got this whole kind of thing in here. Is there a percent? No, there's no percent. But I could have a schema that's, yeah, it's an integer. Yeah, so I've kind of got this capability to define. Oh, that's none there, don't I? And yeah, I could define a whole lot of different settings for whatever field I want. Yeah, percent. There we go. I could send a battery level in percent if I wanted to. So define the fact that this is the thing my device is going to send just through this UI. So to define this, I've got my BitFit, which has got my current activity. That's all I'm sending. And then I can build up views to visualize the data. So I've got one here to show the current activity. I'm showing this just as a single value, but I could do charts and graphs and heat maps. And yeah, if I wanted to show, I don't know, activity over time, I could just plot that on a chart on here. So I've got this capability to just drag on charts. You know, I want to go for, let's go with a device. So I want to do current activity. I can add it, just add tile. There's current activity. We can do this as a bar chart, you know, or pie chart. It's kind of, I say, it's very much kind of click, 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 build up my application, kind of get everything working. So I've got this kind of view on here on my data, and this is my device template. And this is the basic template that's applied to all of my devices. And then from here, I can create a device. So for my device template, I can define a device. And when I define a device, it gives me connection information that's specific to my device. So this is very much keyed off a key. There's a magic key my device needs to connect and identify as a current device. So it's all designed to be secure. And there's loads of cool stuff you can do. You can have X509 certificates. You can have automatic device provisioning, that any device with a certificate gets created automatically, and all that kind of cool stuff. All without me really doing any work, no coding. It just click in here, do my thing. The only code I have to write is on my device. And that allows me to set up a device. And so, oh, the last time my device sent anything, it was sent running 31 minutes ago. So I kind of get this UI to build things. And then from here, I've got a data explorer, so I can build up queries against my data. All my devices, current activity, group by device name. What else is the count of those? Well, I've got 3 things. But yeah, I've got this ability. I've got a whole kind of device explorer. You can see when messages were coming in. I've got the ability to manipulate data in the ways that I want to kind of see my data. I can build some I can build custom dashboards across all my applications, all my devices. I can set up jobs to automatically do things like clean out data, push a message from my device to do things. All this stuff. Just click, 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 get it done. Add rules. Want a rule that if my device shows that it's rowing, go and say, bitfit devices, if time aggregation, so over 10 minutes, if current activity equals, in fact, let's not aggregate, we don't aggregate, so current activity equals running, let's get rid of that, current equals running, send an email, like, yay, you are running. I've kind of got this ability to add these kind of rules to my application. All done here, no code whatsoever. So IoT Central is kind of a great way to get started with IoT applications. It allows me to really quickly click, 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 build up an IoT application. I could use this as the back end for my device. And so I've got my device with Bluetooth. I've got my IoT Central application. So now let's look at bringing those together. So this is where I'm doing this with my Xamarin mobile application. Now, question for the audience, really. Has anyone done any mobile apps? Anyone done any Bluetooth? Anyone done anything of this before where you've connected an IoT device to the cloud via Bluetooth? If you have, put something in the chat. I'd love to know what it is you've been working on. So this is my mobile app. So it's a Xamarin app. It's all done in C#. I used to be a Xamarin person many, many years ago. I kind of gave it up to do IoT. But on my shelf somewhere, I do have, where is it? Where is it? Here it is. Come here. I do even have this great book on Xamarin, written by a guy called Jim Bennett. You may know him from, this very stream where I am streaming. But yes, I wrote a book on Xamarin a long, long time ago. I wonder if it's even got, it did have a picture. I'm sure they put a picture of me in here somewhere. Yeah, I wrote a book on Xamarin a long, long time ago. And kind of quite useful, really, when I went back to do some Xamarin for the first time in a long time to get this working. So yeah, Xamarin allows you to do cross-platform development in .NET. So I can build an application and it'll work on iOS, Android, Mac, Windows, Linux, all those kind of things. And I've built my application just for iOS because I don't have an Android device to hand. So I built an iOS application. And now Bluetooth works differently on iOS and Android. And so one thing that's quite cool about Xamarin is you get a lot of abstractions, you get a lot of libraries that allow you to interact with something like Bluetooth using a standard API. And then behind the scenes, it will use the iOS or the Android APIs. It's kind of quite nice. It uses whatever's there. Behind the scenes, it will use whatever the hardware manufacturer provides. So whatever's in the Apple SDK or the Android SDK. But you get one interface on top of everything, which is really nice. It means you have to learn it once. If you're doing native development, you've got to learn how to talk to Bluetooth in Swift and then talk to Bluetooth in Java or Kotlin or Dart. This allows me to do it just once, which is pretty cool. And the library I'm using is this one here called the plugin.ble. In fact, I might just go to, let's see if we can find this one. Go to, NuGet, nuget.org. This is what we want. And this is the library that I'm working on. This is the library that I'm using. And it's all open source. It's a whole lot of Bluetooth Loangi for Xamarin. So it's pretty cool. So I can install this plugin, install the package, and I get a nice Bluetooth API that I can use. So install this for my application, and then I can start coding up against it. And it has this cross Bluetooth le.current.adapter. So this is kind of just Xamarin terminology for anything that supports multiple platforms is usually done cross something. So there's cross Bluetooth, there's cross speech, cross text, whatever. Just hold it kind of cross whatever plugins. It's kind of just like a standard naming convention that Xamarin libraries use. And then the current good old singleton pattern. If you ever come across a singleton pattern, we're using that one. And then we get the adapter. And this adapter is an abstraction that sits on top of the broad device code. It's kind of a cool thing about Xamarin. You have like a shared library where you access code in a cross-platform fashion, and then in your actual iOS library, you put the underlying implementation that exposes the standard API that you're using. And so from here, what we can do is, if I go down to my actual code that does the thing, where are we? So when my page loads up, I start scanning for Bluetooth devices. So this bit of code does the same as kind of what you saw with the app I just showed. If I just bring up that application again, the light blue app. This is scanning for Bluetooth devices. If I refresh this, this kicks off a scan and listens for Bluetooth devices in the area. And this code is basically doing the same thing. The code here is saying start scanning for devices. And that runs in the background and then fires an event every time we discover a device. So that's looking for my various fitness tracker, my fitness tracker device. So if I go to my code, when we publish the device, it has a name. So every device has a name. If I go back here, you'll see all these devices, most of them have a name. Now it's picked up Bitfit. Let's try and refresh that so it goes back to the other name. Most of these devices got a name. We've got my MacBook Pro. I don't know what a Core 200S is. Got an iPad. Some others are marked as unnamed. They're kind of trying to hide what they are. And so, it's probably, oh, that's an iPhone. Now that it connects, it picks up a name. So sometimes you don't even know what the name is until you connect. That's an FS56A3 from FitShow. Manufacturer name string is FitShow. That could be my rowing machine. I've got a rowing machine that connects via Bluetooth to an iPad. Nope, that's an iPhone. There we go. So it's kind of quite worrying, all this already, when you think about it. The fact I can just scan all these Bluetooth devices. And this isn't hacking. I'm not doing anything sneaky. I'm not finding backdoors. I'm just literally looking for Bluetooth devices. And that one won't let me check what it is. That's pretty cool. Living room. Oh, this is my amp in my living room. So I could kind of connect to this as an audio device if I wanted to. So from a security perspective, slightly worrying. Okay, definitely convinced it must be called Bitfit. But so this is what my code is doing. It's scanning for these Bluetooth devices to try and connect to it. And then we just check on the device name. So I want to make sure I can connect to a device called FitTrack. That's kind of the name I'm going to be using for my device. And so we just look for the first one we find called FitTrack. Now, if I was building a more secure solution, I would find the first one called FitTrack and then do some kind of pairing, some kind of agreement between the two that, yes, we would want to pair and only share data with my phone, not other phones. I'm not going to really dive into security here because I'd get lost with Bluetooth security. But that's the idea, is I want to make sure that only connector, the device got the right name. And then later on, yes, I'd put security to mean connected once and don't disconnect. Then once I got the device, I'd then connect to it, make that connection. Similar to how the light blue app was connecting, similar thing, I'm making that connection. I'm getting the conversation going between my Bluetooth device and my phone application. Then once I've got that, I can start polling for the different services that are available. And so I'm polling for my service that's got a GUID that starts 0D5B. And this is my service here, 0D5B. So because I know the idea of the service I want to connect to, I can start polling for that particular service. And that's kind of one of the quite cool things. I know the service I want, I can go and poll for that. As I said, if it was a standard service like battery, they have well-known, well-defined IDs. In fact, let's see if I can find here we go. Assigned numbers. So there's a whole of assigned numbers for different things. I wonder if it's an actual document with those in them. So there's UIDs for devices. There's a whole of standards behind Bluetooth. That's all devices. What I'm trying to find is see if I can find the actual. I mean, let's just take this blog post here. Hope for the best. How to read the battery level of Bluetooth LE devices. So here, when it mentions, yeah, whatever. But somewhere here, there. So the documentation of the Bluetooth spec homepage lists the number 0x180F as assigned as the battery service. So this is, oh, that page can't be found. So that's the battery service. So if I ever wanted to query the battery of anything, I could connect to a service 180F. So pull through the services, find 180F, and then I can check the battery. And that would work across anything. Absolutely any device that advertises the standard battery service, which is pretty cool. So you've got these kind of standards that I can use. So I'm not interested in the standard. I want my service, which is this one here. So this is the one I connect to. And again, from like a hacking perspective, if I knew the service ID of another device, I could connect to that. So that connects to my service. Then once I'm connected to the service, I can then talk to my service to get all the characteristics. This is the data that can be sent by the device and the data that can be sent to the device. And so my characteristic for my current activity, BC9F, and over here, BC9F. And so it's kind of, the principle is as simple as that. There's a device, connect to the device. Check for services, connect to a service by its ID. From the service, connect to the characteristics by it. It's kind of hierarchy, device, services, characteristics. And then you just connect to that. Once I'm connected, I can then just read the value. And that will actually query the value on the device, get the value of that activity, and then show me that. And these values are sent as bytes, it's binary data. And so what I'm doing is I'm sending it as a numerical value. So inside my code here, this is an enum, 0, 1, and 2. In my code here, I send 0, 1, or 2 Bluetooth. So you saw earlier, it was going 2 when I was running. It doesn't send running, it sends the number 2. You want to keep the Bluetooth data as small as possible. That minimizes battery usage. So sending a number is better than sending like a hexadecimal binary data of the whole string. So once I've got that, I can then update this on the screen, and then I can start listening. This is that notify thing. I can actually say to the characteristic, listen for updates. And when a value is updated, call some of my code. And that's one of the cool things about Bluetooth. It's kind of built into the Bluetooth stack and the Bluetooth Low Energy stack is that you can listen for updates. I just keep listening, and then I get a notification when a value changes, and that way I can update what I'm doing. And so that kind of builds me this nice kind of connection between my mobile app and my Bluetooth device. So let's run this. Let's just run this up on my phone. Oh, just get my face on to unlock my phone. So let's run this up on my phone. Here we go. Disconnect. Oh. So it's the BLE bit we're interested in. It's currently disconnected. Why disconnected? Probably because, it's disconnected because I am connected on my other device. I'm connected from that Bluetooth scanner app. So let me just relaunch my mobile app. I stuck a refresh button there. Refresh button just caused it to crash. I haven't fixed my refresh button yet. So yeah, to refresh, I have to start. But yeah, Bluetooth devices usually only allow one other device to connect. You can't have multiple devices connecting. That's why if you've got like, one phone transmitting, you want to connect 5 different Bluetooth speakers. Depending on the phone, you can, but sometimes you can't have multiple phones connected to one Bluetooth speaker. It doesn't make sense. You can't have one Fitbit sending data to multiple devices. It kind of doesn't make sense. So go here, yep, see we're connected, and the current activity is none. And if I look here at my output, current activity is none. But again, so what should happen, if I go here, strap on my BitFit, my fantastic fitness tracker, hopefully will be available in time for the holiday season, so you can buy your own one of these, so you can track your fitness via the serial port and a terrible mobile app. But if I strap this on, and I do my running thing, get my running on, what should happen in a minute is that current activity should flick to be running. Oh, it's got rowing. Okay, I think I need to retrain my model slightly. Probably don't have enough data. It's rowing. So if I actually try and row, so now it looks more realistic. Same rowing because I'm rowing. Yeah, I think my model was only trained with a minute's worth of data, so I'm going to get discrepancies. It's not going to be perfectly accurate. But you see, it automatically updated. And now if I do nothing, there you go. It's gone back to none. So we've got this update happening inside our mobile app just by listening to the Bluetooth. And that's all just based off the notify from the BLE device. There's no code. I'm not polling it. It's kind of under the hood inside the Bluetooth low energy stack that comes with iOS on the iOS operating system. It just listens to these updates and gets these. And all Bluetooth works the same way. So if I was doing this on Mac, Windows, Linux, if I was running Python code on a Raspberry Pi, doing it on Android, the basic principle remains the same. Device has one or more services. Each service has one or more characteristics. And if it's a characteristic you can read, you can pull data. I can also write to a characteristic. So if I wanted to write to my device to tell it to do something, I could write to it to turn the LED on and off, something like that. I could do that. So Bluetooth allows me to do that. So that's cool. I'm kind of getting, I'm slowly getting a bit closer. I've got the data from my device up onto my phone. The next step is getting that data up into Azure IoT Central so I can see it in the cloud. So as I said, IoT Central, I've got my devices in here. Here's my device that I talked about before. Now the way I connect to this is there's two ways I can connect to IoT Central. I can either connect using a key or using a certificate. And then whether IoT Central knows about me or not depends on, again, how I want to use the key or certificate. So I can either define my device up front, which is what I've done here, and then that gives me a key that I push to my device to connect, or I can put a certificate somewhere. And so I can set it up with what's called an enrollment group so that when I connect with a certificate, it'll automatically create my device for me. So that's kind of up to me whether I want to pre-create devices up front. For a consumer device like this, you probably wouldn't pre-create the devices up front. You put a certificate either in the phone app, or your phone app would download the certificate from the cloud, or somehow the cloud would your phone would provision the device for you. You create it in IoT Central as and when you need it, not earlier. For now, for the sake of simplicity, I'm creating my device up front. So thinking back to like a real world use case for IoT Central, we have worked with Keurig, the folks who make coffee machines, and we are bringing IoT Central to those. So they've got cloud connected coffee machines that connect to IoT Central. Now there's no one at Keurig who kind of monitors all the sales and types in the details of every single coffee machine they get or anything like that. Instead, it's a certificate on the device, connects to the cloud, and gets automatically provisioned. So IoT Central, it's great, but it scales. It scales to global coffee machine supply kind of levels, which is pretty cool. So I've got three values: an ID scope, a device ID, and a primary key. And then what I have to do in my code to connect to here is I have to connect to what's called a device provisioning service. So I connect to that and say, I want to provision myself. I want to make myself work. Here are my 3 bits of information. ID scope is a unique ID for my IoT Central application. Each IoT Central app, different ID scope. Then device ID is my unique identifier. That's me. This is how you identify that. Hello, I'm this device. This is this fitness tracker, not this one. And then my key, which is my magic, I'm going to allow you to connect. And so I can use these bits of information. I connect to the Azure Device Provisioning Service, say, hey, I want to connect, allow me to connect. And then what I get back from the Device Provisioning Service is the underlying IoT hub, which is the kind of basically big message broker that I have to connect to send data that gets picked up by my IoT Central application. So device connects to Device Provisioning Service, says, allow me to connect, gets back the thing that needs to connect to the underlying pipe, connects the pipe, starts sending data. That's kind of the structure of how everything works. And so if I go back to my mobile app, I've got hard-coded in here. Very bad practice. Do not try this at home. But just for the sake of simplicity when building this application, I've hard-coded my values. This is the kind of stuff you'd want your phone to when you log in with your phone to set up your account for your BitFit, you want to download this data from the cloud somewhere. So I've got this here, and then I'm using the Microsoft Azure Devices client library, the Microsoft Azure Devices NuGet package, which is this one here. So I've got the client. This is the client libraries that IoT devices that are written in .NET can use, and this allows me to be a device and then send data to the cloud as a device. And then these provisioning libraries are what allows me to kind of do that initial handshaking up front. Now I've got two transport libraries here, AMQP and MQTT. I'm only using the AMQP one here really, but when your device connects, there's a number of different ways it can connect under the hood. There's kind of protocols for connecting. And they're all based off lightweight message buses. Message bus is like a pipe. You put stuff on one side, things pull it off the other. And so when you connect, you kind of choose which type of transport you want to do to connect. A lot of that depends on just what you're trying to do, how you're trying to do it, or if you're trying to get through a firewall. There is this fun thing where if you've got an IoT device inside a factory where you've got heavy firewalls, you might only be able to make a request over HTTP. In which case there is a transport HTTP you can use, and that basically acts like a web request to try and set yourself up. But if you can do more stuff, then there's different message brokers that can be more efficient. So I install those packages into my code, and then in my connection code here, where we go? In my connection code, in the background, I provision my device. And what this does is this sets up my key, sets up my transport handler, my message broker, to use the handler, and then makes a call to the provisioning server, say, hello, I'm a device, I want access, can I do the thing, please? And that then registers my device. Once I've done that, I get back the assigned hubs. This is kind of the message broker that my messages go to, and then I connect to that using my symmetric key. So it's like, yes, I've been told I've got to connect to this broker. Here I am. Here's my key. Here's my device ID. Let me connect. And I've got my kind of key, which is my device ID and my unique key. So this is who I am. This is my device, and that then gives me a connection. And once I'm connected, I can just sit there and I'm connected to IoT Central, and IoT Central knows I'm there. It's kind of got like a heartbeat that goes on and off in the background. And once connected, I can start doing stuff. So in fact, if I just run this, make sure this is running, while I'm starting that up, you'll notice here, IoT Central sees me as disconnected. So it's not getting the heartbeat from my device because my app is currently not running. Unlock my phone. So in a second, my app will connect. If I go to my app, connect. It's going to start connecting to IoT Central in a second. Connected. If I actually look in IoT Central, maybe just reload this. Okay, it takes a couple of seconds for it to feed through, but eventually this will say connected. It's updated a minute ago. Okay, but yeah, in a second that will show connected because my device is now connected to IoT Central. Always a bit of a lag because data has to go around, systems do things, what have you. Okay, so yeah, in a minute that'll show connected. So that's kind of got that connection going. And then what I do is I can then send data. I'm connected to it, I can send data. So in my code, whenever I receive an activity, whenever I get this activity from the Bluetooth low energy connection, where is it? So I've said every time my characteristic is updated, call this value updated method. What this does is it gets the current value, updates the activity, and when I update the activity, as well as updating the UI, I send this to IoT Central. So I send my telemetry payload. Then from here, I build up a JSON document. So a lot of messages in IoT Central sent as JSON, JavaScript object notation, key value pairs inside wobbly braces. I send my current activity as the actual text I'm showing, none, running, rowing, create a message, and then send it. And that message then goes up to the cloud, and I can see the data in the cloud. And so if I look here, come on. So there's some telemetry. This is the actual telemetry that's received. It's raw data, current activity none. So this is what I send the message, none. And then this timestamp and event type, that gets populated by the IoT libraries. Timestamp is quite cool because if I want to do time series analytics, which is where you look at data over time, I've got the timestamp embedded in my code, which is pretty cool. And so now, if I'm connected, if I change my activity, so I put on my my BitFit, put this on, and I start doing my running thing. Here I am running. So in a minute, if I just go to my phone app, there you go, current activity running. So my phone's picked up that I'm running. If I zip back here, there we go, current activity running. Don't know why it's still saying disconnected. Okay, now it's saying none, but we should have here, here's the raw data, here's running, that was just received. And then none, it picks up the none. Obviously not running well enough, you know. So my model's not perfect. I trained it like a minute and a half's worth of data, so it's not perfect. Let's try some rowing. See if we can get, see if rowing is gonna pick that up. Second, here I am rowing. Come on, pick up that I'm rowing. What if I'm rowing a bit too fast? Yeah. Definitely need to make a few tweaks to my model. That's what's great. I can just gather more data, train it. Let's determine the fact I'm doing nothing. Let's try running again then. Come on. Oh, running. That's picked up running. And if I go back here, you see, running. So I've kind of got this great flow from a Bluetooth device. This device is using not much power. It's running away. It's running, no pun intended. Yeah, I can run this off a battery. So it doesn't draw that much power, but that, using Bluetooth, sends it to my phone, which has got the bigger battery, got the internet connection, got Wi-Fi, cellular, whatever. And then from my phone, it goes all the way up to Azure IoT Central, and I can see my data here. This is pretty cool. Oh, back to none. So, don't know why it's still saying disconnected. It is very much connected because I'm getting data. Oh. So there we go. That is my whole TinyML based fitness tracker. Now my model needs to be improved. So if this was a commercial device, I would probably look at how I could gather more data from the device. Yeah, if I was training this, take for example Apple recently with their Fitness Plus, they wouldn't have done, you know, a minute and a half's worth of data. It wouldn't be, is it a minute and a half I got? 1 minute 27 seconds worth of data or something that I'm using. Yeah, 1 minute 27 seconds. No, ideally you want to capture thousands of hours of data. You want to strap this device to runners, catch them running, get people doing nothing, people rowing. You can build up a wide range of different data sets. Thousands of hours of data. That's why in IoT, a data scientist is your best friend, because IoT devices are all about data, gathering it and using it. And so get the data, I could train the model to be perfect, or as pretty, well, maybe not perfect, but pretty good. And then I can just deploy a new model to my fitness tracker. Just need to update my little device, my Seeed XIAO. That would then improve my model, and that then feeds via Bluetooth from the device to my phone up to the cloud. So there you have it. That is my fitness tracker from start to finish. What I will do is I will give you all the code. So I've got a GitHub repository here. I will just put this in the chat for you all. There it is there. And this has got all the code in it. So you've got the you've got some of my data. So you want to actually import my data. You don't want to test yourself. We've got the data there. You've got the device code. We've got the capture code, which just pulls back data from the device, so I can send up to Edge Impulse. You've got running with the classifying board, so you can just see whether you're running or rowing. And then you've got sending it over Bluetooth. And then I've got the mobile app code all in here, where you can actually get the code sent up. Yes, without my keys in there. I took those out. I'm not silly. And don't worry, I'm going to be rolling my keys anyway, or deleting the app, so you can't hack me. But yeah, all the code is here if you want to have a go yourself. So please have a go. Let me know how you get on. I'm all over the internet, Jim Bob Bennett, Twitter, GitHub, Instagram, LinkedIn, whatever. Please let me know how you get on with this, what you build with it. But otherwise, yeah, thank you very much for joining me. And Irene is trying to wrap us all up, but she's on mute.
Of course, once again, I just live on mute. I apologize, everyone. Thank you, Jim. Thank you for calling me out on being on mute, and thank you for your presentation. And thank you, everyone, for joining. We appreciated having you here. If you have any feedback, we'd love to hear from you. The link can be found in the chat. I will show it at the bottom as well, and the event code is 15691. We'd love to hear from you. Until next time, bye.
Thanks. Bye, everyone. Bye, Darren, Doc Robinson. Thank you.